Let's take a look at example 22 here. Consider the sequence 2, 5, 10, 17, dot, dot, dot. Okay, write down an expression for S of n. Okay, so what we really want to do is we want to come up with what's our use of n, what's our formula for this here. Okay, so let's do that. We've got 2, 5, 10, 17. So we got use of n equals use of 1 plus n minus 1 all times d, right? So our formula, our use of 1 is, first term is 2, and then we have n minus 1, and then the difference, we're adding 3. Let's see, oh, we're doubling it. No, we're not. 2, 5, 7, sorry, adding 3, adding 5, adding 7, so we're adding a different number each time, okay? Okay, so if you notice on this one here, let's see, what's happening here, really 2 is 1 squared plus 1, 5 is 2 squared plus 1, 10 is 3 squared plus 1, and 17 is 4 squared, 4 squared plus 1. So really, instead of doing all this here, okay, really what we're trying to figure out is how do we come up with each term? Okay, so actually we don't need this either, because what we just did is we figured out that this is the term squared. So like 1 is the first term, 1 squared, and then you add 1. Second term, 2 squared, and add 1. Okay, so we figured out how this sequence works. All right, so what we can do is say, okay, we can start with our little sigma notation here. Supposed to have these little feet on the end here. So we are going to have our k equals 1, okay, and then our formula we figured out is going to be our k, or whatever our term number is there. It's going to be k squared, and then we're going to just add 1. So we're going to add 1 to each term, right? Okay, and then in this case here, we don't know where it stops. It keeps going on forever and ever, so our last term is going to be n. Okay, so this is our expression for S of n. Okay, so again, this means starting with 1, going up to whatever n ends up being, which we don't know because it goes on forever and ever. Basically just trying to figure out how do we figure out what each term is. So again, some of them you're going to have to kind of look at and try to figure out what the heck's going on. Some of them will be easier, some of them will be a little bit more difficult, but just keep working at it. If I've found that if it's going up by a different number each time, it's usually going to have some kind of like square in there, and that usually, if you start with that, if you've got adding by a different number each time, then that will usually help you figure out what's going on in that. Okay. Anyway, find S of n for n equals 1, 2, 3, 4, and 5. So what we've got is we've got S of 1. So the first term, we put a 1 in there. We already know what that is. That's just 2, right? So the sum of just 1, the first term, is 2, because that's the only one we have. S of 2 is going to be the first term plus the second term. So that's going to be 2 plus 5. And that's going to give us 7. Okay. S of 3, 2 plus 5 plus 10 is going to be 17. S of 4, our fourth term is going to be 2 plus 5 plus 10 plus 17 is going to be 34. And then S of 5, 2 plus 5 plus 10 plus 17. We don't know the fifth term, but we can figure it out, right? Because we can plug 5 in. 5 squared is 25 plus 1 is plus 26. So really we're just adding on this 26 to the 34, right? Which gives us 60. Okay? All right. Okay, I think we're going to end this part here and pick up on video 2 here in a little bit. So if you have any questions on any of this, please feel free to ask in class. Thanks.